Okay, let me start with the introduction first, right? So, well, hello everyone. My name is Anmol Shah, and I'm an associate software engineer at truemark. And today I'm going to talk about the single responsibility principle, which is one of the solid design principles. Now, before actually diving deep into the single responsibility principle itself, I'd first like to talk about what the acronym SOLID is and why do we need it. So, SOLID was introduced by Robert C. Martin in his paper in early 2000s, but the acronym was introduced by another computer scientist called Michael Fedges. Well, SOLID is basically a set of principles for object-oriented design with major focus on designing the classes. Now, why do we need to design our classes? I mean, so why not just implement it? Why even bother designing the classes in the first place? So, to put simply, it is necessary to design, well, it is necessary to design our classes such that our changes can be controlled and is predictable to the most part because uh, well, when we like in, so when you incorporate design in your classes or component, it helps you create understandable, readable, testable code that many developers can collaterally work on. Um, so moving on, what is the importance of solid? I mean, why do we actually need it? Just like I said, because I mean, so incorporating design is actually very helpful to create a readable or understandable code because in the longer term, it helps to keep our code decoupled. It means dissociated and make our code uh, extremely modifiable and testable and understandable as well. Because oftentimes what we see is in our code base, dependency is the major problem at all scales. Uh, and it doesn't matter if your code, well, if you have just started with your application or have hundreds of thousands of users in your deployed application, because uh, because unhealthy dependencies can actually bring complexities to your classes that will be unmanageable in the long term. So uh, yeah, well, moving on. Code smell. Why do so? Does our code actually smell, and how do we know if it smells? Well, code smell. Well, according to Wikipedia, code smells are certain structures in the code that indicate the violation of fundamental design principles, which negatively impacts on our design quality. But do note that code smells do not mean bugs or compile errors or non-functional code. It only it's a service indication. Well, it's a service indication that the classes have been designed poorly, which is what is in case. Now let's take a look at well in example here. So we have three classes here, and all three classes have date formatting code in it. Now the initial requirement was to format the code as DD, MM, and YY. Now let's say a new requirement has come where along with the date, we need to format the timestamp as well. So what do we do? Uh, so in this case, we need to manually go in each class and have to update that date formatting code or method uh, in those classes manually, which is a tedious task. I mean, just try to imagine if there were no three classes, but if there were hundreds of classes, what would you do? Would it be a tedious or a daunting task to actually copy and paste the same date formatting code and update in every single classes because that can also produce bugs and can crash the application at one point if we were to miss just one class uh, to miss the update in just one class. So what can you do in this situation? So what can be done is so we can actually abstract or extract our date formatting code into a helper function so that our changes can now be narrowed down to just a method, which can be imported to hundreds of classes, and it doesn't matter. And all we need to do is we can just uh, update our date formatting code in that helper function. So it's no longer needed to be updated in every single class manually. Now, moving on, symptoms of routing software. So how do you know? So how do we know if our application is actually rotting, if the design have been failing? So there are four symptoms that actually do indicate that our software has been rotting. And the first one being rigidity, which is the state of the code or where where it where the changes is very difficult uh, where the changes is very difficult to make without causing any problems, because what happens is, as making changes in one part, it prompts the need to make changes in other parts of the code, which may bring which may impact other numerous classes as well. Now, the fragility. So fragility is the state of the code where changing code usually breaks the behavior of the software, and it can even break the parts that are not directly related to change. Now, the third one being viscosity, which is how complex our application is. That means how complex our code base is. So when a software is difficult to change, we keep adding complexity to the software instead of making it any better. So we can't abstract away the complexities, but we rather keep uh, adding complexity in the same application. Now the last one being immobility. Immobility is actually how reusable a piece of code is, how reusable our classes are, because because uh, well, although some parts of the application may have similar behavior, we are unable to reuse the code and must duplicate them, which brings um, unhealthy dependencies. Now, I'd like to draw your attention towards the bottom left image, which shows, and on the far left image, which it shows, this diagram shows there's uh, a tightly coupling between classes, which indicates that our classes are uh, strongly dependent on each other, which is not a good trait to have in our classes, because that leads to frequent crashes and unexpected bugs. Because well, for instance, changing this class may bring a disaster change on this class as well. Now, on the far left image, we can see the dependencies between classes are very minimal and viable. And these type of dependencies is called loosely coupled classes, because the dependencies between each class is weakly. It's very weak, and they're not dependent on each other. So that means the changes can be managed pretty well. So it's maintainable at the very most. Now, finally, to the main topic, the single responsibility principle. So what does this principle state? So according to this principle, there should not be more than one reason for a class to change, because now now uh, now that this principle is self-defined, that a class should not have more than one responsibility. So what it can help us it can help us achieve to uh, to extend quickly, and it will also help it can also help us to adjust our classes without producing any new bugs. Well, because classes that narrowly do what they were intended to do can actually bring fewer bugs. Because so see, when we try to mix responsibilities, it becomes something like a sport, which is not something that we want, because Just by looking at it, we can see it brings discomfort to our eyes, and we don't want it. So our single responsibility principle defines it clearly that for a single class, there should be a single responsibility. Now, what is the importance of this principle? It avoids, well, it helps us to avoid modules incompatibility, even when team members try to edit the same class for different reasons. Uh, as a team, when we work in the same project, we try to edit the same class. So number of persons just try to access and edit the same class, and that may bring several merge conflicts or and bugs and crashes. But now that our responsibilities have been defined and dissociated, we know that a programmer who try to change that class is only going to edit it such that it is to justify for that responsibility. It's not going to be changed for any other thing. Uh, well, because our responsibilities have been defined clearly, which also makes our version control easier because it is easier to manage our merge requests, or pull requests for that matter, uh, and also and it also helps us to reduce our dependencies between the classes, and then it also helps us to scale our classes and maintain our code base. Now, moving on to the violation principle. Now, I'd like to imagine a class. Now, I'd like you all to imagine a class called user. Now, this user class, now the initial functionality of this class is to actually generate a payslip of an employee. It's very simple. To generate a payslip, all we need to do is instantiate a user object and call that method. That's it. Now, let's say the requirement has changed. Now, after generating the payslip, we need to send that payslip of an employee to the employee's email monthly on a monthly basis. So what do we do? Now, without following the single responsibility principle, we could add another method called send email, and after and well, then after we have generated our payslip, we can just email that to the employee. But it violates the principle because the this user class is actually sorry, pardon me. This user class is actually handling two responsibilities. It's generating a payslip as well as sending emails, which is what so it violates the principle. Now, how do I refactor this code such that it also abides by the single responsibility principle as well? Well, you guessed it right. We can just dissociate those responsibilities into two different classes. Now this approach helps to decouple the responsibilities and ensures a predictable change because for whatever reason, if I had to change anything in this class, it has to be to change the implementation on how we generate our payslip, and we will not be touching this class uh, 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 besides anything for the besides anything. This is like responsibility. So similarly is the case for this mailer class, where we will just be implementing this. So yeah, we will just be modifying this class if we ever have to change the implementation by sending the email to the employee. Now, it also helps us to predict any changes in the functionality. And so is the example that's refactored in JavaScript. I'd like you all to take a look at it for a while. All right, moving on. So how can we actually implement single responsibility principle in Ruby? And one way is to actually move the business logic from controllers to service objects. Now, service objects are nothing but plain old Ruby objects that are designed to execute one single action in a domain logic and do it well. Because oftentimes what we do is when we have a feature that needs to authorize a user and process some payments and send emails, we tend to add all of that code inside either a modal method or a controller action. But that's not where those codes should go, because it only adds complexity in our controller actions as well as in the modals. So those codes, they all should be extracted to uh, to its own service object. Uh, well, another way to actually implement single responsibility principle is to group the methods and constants inside modules, because modules are a great way to group together module classes, methods, and constants. Similarly, we can extract the modal logic into concerns. Now, concerns are just modules, but they do provide a way to actually put code that you want evaluated inside the included block. And similarly, we can create utility classes for maximum code reusability. Finally, the conclusion. Well, now the single responsibility. And now the principle provides us a principled way to actually manage our dependency, because it is a principle, the S in solid. So it helps us to manage our dependencies by actually helping us dissociate our code properly, and that results in code that are flexible, is robust, and reusable. And by robustness, I mean how well is the application handling errors, how informant it is for developers to actually will provide the necessary information for the programmers to actually debug that piece of code. Yeah. Similarly, a well-designed code base is adaptable, simple to modify, and is pleasurable to work with, because even a new developer can collaboratively work on it, because if the code base is well designed and when the responsibilities are dissociated and defined in a convenient manner. But that wraps it all. Thank you all for patiently listening to me. Now, if you do happen to have any questions for me, I'd be happy to answer them. Thank you.